Okay, let's do homework 5. Question number 1. If you use 0.05 level of significance in two-tail hypothesis test, what decision will make if z stat is negative 1.48? So before we start working, let me explain what is a hypothesis test, although you're supposed to know, but let me refresh your memory. Hypothesis test is the claim that we are going to test. We're gonna believe that whatever claim you say, it is true. Okay? And there is also alternative one. So we have null hypothesis and we have alternative hypothesis test. So we always gonna test null hypothesis, and your claim can be either null hypothesis or alternative. Why we always claim null hypothesis? Because null hypothesis always gonna, let's say we are checking testing claim on average mu, it's always gonna carry equal sign. Alternative one, it can be not equal, it can be less, it can be greater than, it can be less equal, it can be greater equal. So mu is the average of population. You can test also deviation, you can test also proportion. So we are going to work with possibly with mean if we get to calculate mean. But for now, I want to refresh your memory. So the claim that's going to be either null or it's going to be alternative, either way, if it claims that it's less than something or greater than something or not equal or less equal or greater equal, then it goes to null, alternative hypothesis. But if the claim is about equal, let's say it claimed that the average is equal this much, whatever, then it's gonna be null hypothesis. And we always gonna test null hypothesis because it carries equal sign. Okay? Now, what is the level of significance? In our case, we had a level significance level 0.05. What does that mean? How do we interpret? That means that there is a 5% chance, because 0.05 it's a 5% chance of incorrectly rejecting null hypothesis. So when do we reject? When we don't fail to reject. We reject when we see that the claim is not equal what they claim. It's let's say greater or less or not equal or whatever. Then we reject this null hypothesis. But if it's equal, which means we accept it, in language of statistics we say fail to reject. All right, that's what it is. So that means 5% significance level is 5% chance to incorrectly reject null hypothesis when it's actually true. Let me understand which area we are going to reject, which area we are not going to reject. So this is our normal distribution. We are going to work with normal distributed data, which means it's a bell shape, and main data are located here. And what do we have these lines? What are those? Those are critical values. Okay. This critical value is this line and this line. Critical value is the separating trustworthy area, which is this one. We don't reject null hypothesis if it's falling in this area, and we reject null hypothesis when it falls this area That's what we call the rejection area. Rejection area, this area. When we are talking area, that means we are talking about percentage, which is probability. Okay? Rejection area. Okay, so how we gonna figure out? So given, let's go back to our problem. So given 0.05% level of significance in two tails, by the way, we can have the graph or database can have two tails, like here we call rejection area tail. It can have one tail. Let's say in this case it's gonna be left tail, and we can have right tail. In this case it's gonna be only right tail. Okay, so it's telling us it's about 0.05 significance level for two tail. Okay, which we're gonna take this. So this area and this area is 0.05, okay, together. So, and we need to find that z-score, this critical value, it's about a z-score, okay, some z-score. And with the z-score we are given, we want to find out this given z-score, z-stat, negative 1.4, negative 1.48. Is it falling to the right or to the left? Is it this z-score falling to the right of this one or to the left? Because if it falls to the right, then we fail to reject. We need to accept. If it falls to the left, that means it's in a rejection area. So let's solve the problem so we can understand. So we have 0.05 of these two rejection areas, since we have two tail. So one tail will be alpha half, because this is alpha, we call it alpha. So to get for one tail, we have to divide by 2, and we get 0.025. Yes? Okay. So next step, what we're gonna do, we're gonna go to the table. 0.025. In this table, these numbers you see in the body, 0.000 blah blah blah. This is this is your alpha, okay? Or in our case, it's alpha half. And left and right, let's say z-score, you see it goes negative at 6, negative 5.5, and here is decimal notation. Yeah, those are z-scores. So our work is find out this region, how much this rejection region, when it's end, with what z-score is splitting here, critical value. Okay, so we are going to take 0.025. Let's find it. 0.025. Oh, 0.027. Let's see, 268, 256. Here it is. 0.025. It's right here. See, I'm zooming so you can see. Can zoom. 0.025. So let's see which z-score it's gonna match. 0.025. If I go horizontally to my z-score, it's gonna be negative 1.9. And now to get how much is decimal portion, 0.025. If I go up, this is gonna be this column which ends with 0.06. So which means it's gonna be, let me explain also, negative 1.96. So z critical It's going to be negative 1.96. How did I figure out? Let me show you real quick. Let's say we found 0.025. First, I'm going this way, find whatever z-score I have here. It's negative 1.9. And then I'm going up. It will be 0.06. Putting together, negative 1.9 and then 0.06. So you get negative 1.96. You are adding, you ignore this negative sign, you add them up, and then at the end you touch this negative sign, negative 1.96. So what does that mean? That means our Z critical is negative 1.96. Since we have positive, we have this area also. This side is negative, this side is positive. Okay, this is 0. That means below 0 is negative, above 0 is positive. So that means it's going to be, since we have two tail, we're going to have and negative 1.96 and positive 1.96. I hope I could refresh your memory. Okay, 1.96. Okay, we identify critical area. Now we need to take what is our z-score statistic, negative 1.48. Z statistics is negative 1.48. Where is gonna fall down? Negative 1.48 is greater than 1.96, negative 1.96, and less than positive 1.96. So it's falling in this healthy area, correct? So what does that mean? Let's go back here. If it's falling between negative 196 and positive 196, then we don't reject, right? We accept. Look here, in between we accept. It's a healthy area where that's where our data. But if it's falling here, then we reject. Therefore, it says, when do we reject null hypothesis? We reject if it's less than negative 196 or greater than 1.96. Which means this area, if it's greater or if it's less, right? Then we're gonna reject null hypothesis. Okay, now what conclusion you can choose? Since z-stat does not fall into rejection region, then we do not reject. Correct? We already discussed. So it falls between two critical values. That means it's a healthy area. We do not reject. All right. Question number 2. What is this one? It says, if you use 0.1 level of significance level to tell hypothesis test, the decision for rejecting null hypothesis mu is equal 14.9, and if you use the test as it shows below. Okay. How we gonna figure this out? So, first of all, we are going to identify which area it's gonna fall, right? It says reject null hypothesis if z-stat is less than negative 1.645 or greater than 1.645. So which means it's going to opposite direction, right? Negative 1.645 and positive 1.645. So it's either greater or less. Then we reject. Indeed, because it's falling in rejection area. So What's your decision if stat is negative 1.45? So let's see, negative 1.45, it's greater than negative 1.645, right? Remember? Negative 1 point, let's say somewhere here, 1.45, it's greater than negative 645 and less than 645, so it's falling in healthy area. Excuse me. Hence, we don't reject, right? It says since this stat falls in the non-rejection area, that's what I call healthy area, we do not reject null hypothesis. In statistics, they don't use the verbiage accept. When it's come to null hypothesis, they use reject or fail to reject, okay? So we do not reject null hypothesis. Next one. Now we need to identify p-value. What is p-value? P-value is this area, the probability. How many percent is this is p-value? It's a p-value is a percentage of rejection area. All right? So let's see what we can do here. In two-tail hypothesis test, p-value is 0.0586. 0.0586. What's your statistical decision if you test the null hypothesis at 0.05 level of significance? Okay, so since we have p-value 0.0586, all right, and null hypothesis at zero significance level of significance 0.05. Significant level 0.05. Since we have two tail, so I'm to get for this is p for both areas, 0.0586. So if I split, right, for one tail, 0.0586 divided by 2, I'm getting 0.0293. Yes, and the same level, same way is it has to be a confidence level, 0.05 divided by 2, 0.025. So we need to compare to each other. So is p-value is greater than confidence level? This is p-value divided by 2, and this is alpha divided by 2. This is what we have, and this is what is given, what's supposed to be. Is it greater than the alpha half? Yes, 0.0293 is greater than 0.025, which is falling in this area. If it's greater, then we do not reject null hypothesis because it's falling in healthy area. Let's see, since p-value is greater than alpha, do not reject null hypothesis. Okay, very good. Moving to next question. Number 4. What is p-value if in a two-tail hypothesis test z-stat is negative 2.0? Okay, what we're gonna do? First of all, we need to find z-stat, how many percent is the p-value for z-stat negative 2.0. Okay, negative 2.0. So we need to open, so from this stat we need to get probability percentage, which means I'm going to go to negative 2.0. Since we are given only positive, so I'll use positive and then flip to negative sign, because it's they are symmetric, right? Positive and negative. So 2.0 I have here, 2.0 z-score, and because we don't have 2.01, 02, we just have 2.0. I'm taking 0, the first column. So 2.0, I get 0.9772, right? Okay, let's see what we get. 0.9, hold on, and down, let one more time. Negative 2.0, 0, oh, we have here, okay, negative 2.0, 0.022h. Oh, I had I was in the second one, or what? What page was that? I was looking. No. Let me close this window so this noise won't bother. 1 second, please. Okay. So, negative, I don't know what the page was open, but that's all right. So we have the z-score negative 2.0. Maybe I was in wrong place, I don't know. Negative 2.0, and I get 0.0228. 0.0228. Did I write down correct? 0.228, correct. 0.0228. And if I multiply by 2, because we have two tails, right? This stat is we have this stat is negative 2, which means it's on negative side. This is only one side, 0.0228. But because we have two tail, right? It says two tail. When we need to multiply by 2, and you will get this answer, 0.456. See here, it's mentioned two tail. If it would say left tail, then we would take 0.0228. That would be the answer. If it would say right tail, then we would take the positive 0.228. But it says two tails, so we need to multiply to get for both tails. Okay, moving to next question. All right, what do we have here? If in a sample n is equal 16 from a normal population, let me write down n is equal 16. I think this one I can use calculator. Let me see. No, that's not. No. Hold on, I'll find out. If n is 16, selected from normal population, x bar is 52. X bar is our average for the sample, right? Sample mean. S is a standard deviation for the sample. What's the value of t stat? If you are testing the null hypothesis, mu is equal 50. Let me see if I can find it. For t score for hypothesis. Okay, let me see. T-test calculator here. P-value, T-score. No, we need to do math here. No. Let me test the rest. Here it is. Here it is, sample size. We have it here, everything. Okay. Very good. Let me take the picture of everything. Why is it not? Ah, here. So I'm going to take a picture of this data so I can plug in. All right. T-statistics. I will put under the video. So what do we have? N is, I have 16. Where is my N? Here. I put 16. Okay. X bar, which is mu. Here it is. I have 52. Deviation is 8. And the mean, we are going to test the mean 50. Let me see if we get the answer. Okay. Where do we calculate? Where is it? Share result. I don't need share result. I need you to show me the answer. No. Yeah, it won't. I don't need all this. Ah, T-statistics here. We could calculate it. It's 1. Let's go to homework and check. Indeed, 1. Okay, so I will share this T-statistics calculator. You are going to plug all this data and get T-statistics. Okay, T-statistics is something like z-score, but for small sample size. When we have large sample size, then we use z-score. When we have small sample size, then we use the T-statistics. What's the cornerstone? When do we consider as a large sample size? When we consider as a small? If it's 30 and above, we consider large. Above 30, it's a large. Below 30 is the small. So if it's less than 30, you use T-score. If it's above the 30 sample size, you use z-score. Now you would ask, how about 30 itself? 30 itself, you can use z-score and T-score. So it's going to be the same way. Okay? Question number 6. It's the same thing. So you can, here it's asking degree of freedom. Okay. Degree of freedom we need for calculation of probability when we have T-score table. And degree of freedom is always equal sample size minus 1. Degree of freedom is equal n minus 1. Let's see how much is our sample size. Sample size is 16. N equals 16. That's our